Have you ever wondered how a star is born? It all starts in the nebulae, these colossal clouds of dust and gas that exist in the vast expanse of space. Within these nebulae, gravity plays a crucial role, pulling together particles of dust and gas. As these particles continue to accumulate, a protostar begins to form. But a protostar is not yet a star. It needs to undergo nuclear fusion, a process that occurs in the heart of the protostar. Here, hydrogen atoms combine to form helium. This fusion reaction releases a tremendous amount of energy, causing the protostar to heat up and shine brightly. This fusion reaction is the star's lifeblood, providing the energy it needs to counteract the force of its own gravity. It's a delicate balance, but one that allows the star to shine for millions, even billions of years. And voila, a star is born, ready to shine in the galaxy. Now that we have a newborn star, what comes next in its life? Well, here begins the long, stable phase of a star's life, the main sequence. During this period, a star truly comes into its own. Imagine it like this. The star, now a radiant celestial being, begins to shine brightly, lighting up the vast cosmic stage. This spectacular illumination isn't just for show, though. It's a result of a powerful process happening deep within the star's core, nuclear fusion. Now you might be wondering, what's nuclear fusion? It's essentially the heart of a star. It's the process where hydrogen atoms, under immense pressure and heat, merge together to form helium. This reaction releases vast amounts of energy in the form of light and heat, causing the star to shine brightly in the cosmos. This is the same process that powers our very own sun. But here's where things get interesting. The size, color, and temperature of a star depend on its mass. Larger stars burn hotter and faster, their passionate lives ending in a blaze of glory. They are the brilliant blue giants of the cosmos, living fast and dying young. On the other hand, smaller stars like our sun are more measured. They burn at a slower pace, their lifetime stretching over billions of years. They are the reliable yellow dwarfs, providing stable and life-sustaining warmth. So, while the life of a star might seem like an endless spectacle of light and heat, it's essentially a cosmic dance between two forces: gravity, pulling everything inwards, and the pressure from nuclear fusion, pushing everything outwards. This delicate balance is what determines the star's size, brightness, and ultimately, its lifespan. Therefore, a star's life is not just about burning brightly. It's a complex interplay of cosmic forces, a delicate dance of elements under extreme conditions, and a testament to the dynamic nature of our universe. So a star's life is a delicate balance of gravity and nuclear energy. Ever wonder why stars twinkle in our night sky? Well, this sparkling spectacle is due to a fascinating process taking place millions of miles away. Stars, like our very own sun, are fiery balls of gas. At their core, nuclear reactions occur, fusing hydrogen atoms into helium. This process, known as nuclear fusion, generates immense heat and light. This light doesn't just stay within the star, it radiates out into space. Traveling at a staggering speed, the starlight embarks on an interstellar journey that can take years, even centuries to complete. But the journey doesn't end there. When this light reaches our little corner of the universe, it has to pass through Earth's atmosphere. The Earth's atmosphere is like a turbulent sea full of waves and currents, causing the starlight to refract or bend in different directions. This bending of light gives us the twinkling effect we see from the ground. So the next time you see a star twinkling, remember the fascinating science behind it. What happens when a star's life comes to an end? That's a question that has intrigued us for centuries. You see, stars are not immortal. Just like you and me, they have a life cycle, and when they exhaust their nuclear fuel, their life takes a dramatic turn. The once vibrant, shining star begins to expand, transforming into what we call a red giant, or in some cases, a supergiant. This expansion is the star's final attempt to keep the nuclear reactions going. But alas, it's a losing battle. When a star finally exhausts all its nuclear fuel, it faces a crossroads, a cosmic coin toss that will determine its final fate. One possibility is a gentle, albeit spectacular end. The star, now a red giant or supergiant, begins to shed its outer layers. These layers drift away from the star, creating a beautiful, glowing cloud of gas and dust known as a planetary nebula. The heart of the star, now exposed, cools and contracts. becoming a dense, hot core known as a white dwarf. However, for more massive stars, their demise is anything but gentle. Instead of slowly shedding its outer layers, the star goes out with a bang, literally. It explodes in a brilliant display of light and energy, an event we call a supernova. This explosion is so powerful that it can outshine an entire galaxy, if only for a brief moment. What's left after this cosmic fireworks display? Well, that depends on the mass of the original star. If it was relatively small, a dense spinning core known as a neutron star is all that remains. But if the star was particularly massive, its core collapses under its own weight, forming a black hole, a region of space where gravity is so strong that not even light can escape. From birth to death, a star's life is a fascinating journey of cosmic proportions. And while the death of a star may seem like a tragic event, it's a necessary part of the cosmic cycle, paving the way for new stars to be born. So, let's recap the incredible life journey of a star. It all starts in a nebula, a vast cloud of gas and dust, where gravity pulls the particles together to form a protostar. As the mass increases, so does the gravitational pull, leading to a rise in temperature and pressure at the core. This triggers the process of nuclear fusion, marking the birth of a star. The life of a star is largely dictated by its mass. The larger it is, the shorter its lifespan, burning quickly through its nuclear fuel. The star shines due to the energy produced by the nuclear fusion, lighting up our night sky with its twinkle. Finally, the star reaches the end of its journey. When it exhausts its nuclear fuel, it undergoes a dramatic transformation, possibly becoming a white dwarf, neutron star, or even a black hole. So, there you have it, the mesmerizing life story of a star, from its birth in a nebula, through its long, shining life, to its dramatic end. The next time you gaze up at the night sky, remember the incredible cosmic journeys each star has taken.